In this video we're going to continue talking about complex numbers, and we're going to look at how to multiply and divide those. And when we talk about divide, we have to consider the conjugate. So multiplying complex numbers, we'll call that I equals square root of -1, I squared is equal to -1. So I see two binomials being multiplied together, so I can just think of box or FOIL. I do FOIL, so I would do 8 times -3, 8 times -9, -4i times -3, and -4i times -9i. So we end up with these four. Right? And then typically from here, we combine these two middle-like terms. But we also end up with this I squared here. So let's just kind of go through step by step. -24 stays the same. We combine these two and we get a -60i. But then I squared, we need to remember that that is the same as -1. Right? So we prefer I squared over I if we can get that, because then that eliminates the imaginary component. So all of our complex numbers should have the real component and then the the imaginary component where it's just I. We don't want I squared in there. Well, since I squared is -1, this is actually the same as -36, so I'm going to combine that with this constant here. So we actually get -60 minus -60i. And you might think, well, I can just factor, this isn't deleting, there we go. I can factor -60 out. Well, then it's not really written in complex number form or notation, so we want to leave it like this. So we've got our real component here and our imaginary component. Dividing, we, similar to not having a rational in the denominator, we don't want an imaginary number in the denominator. So how we can get rid of that is by multiplying by the conjugate. And the conjugate is this same complex number, but minus. So it's actually a difference of two squares. So if we take a look here, if we multiply the bottom by 2 minus 3i, you'll see that we end up getting rid of our imaginary component. Similar to if you multiply a rational by itself, it kind of gets rid of that, not a rational, a radical. You get rid of that radical in the denominator. But we can't just multiply the denominator by 2 minus 3i, we have to multiply the numerator as well, because this is the same as 1. So while this is looking very different once we multiply by these, we're not changing the actual value of this. So now we have to multiply across the top and across the bottom, and this ends up just being two different multiplication steps here. So once we multiply everything out, on the top we get these four terms, and then the bottom these four. Remember, we're going to combine the middle terms, and then we have to change this I squared to -1, and then combine that with the constant that we have at the beginning. So we end up with 8, and this is going to be -15. And then we combine this, so we get -7 minus 22i. And then we have, this is a -9i squared, so I squared is -1, so this is the same as +9, so 4 plus 9. And then notice how these two are going to cancel out. And that's what we were looking to do. So that's why we multiply by this conjugate here. Okay. Again, conjugate is the same complex number, but the imaginary component is the opposite sign. So now we have a new rational without an imaginary number in the denominator, but we can't leave it like this. Right? We still need to have a real component and an imaginary component written out separately, like a binomial. So we just write, kind of split this fraction here, so they both have denominator of 13, and this is our real component, this is our imaginary component.